Welcome back. I encourage you to play with Visualgo and create your own graph as I talk throughout these videos about depth first search and breadth first search when it comes to graph traversal. The way you can create a graph is to just simply say draw graph, and you'll be able to create something like this yourself. And then you can explore both depth first and breadth first searches. Now, I'm going to have this animation running while I'm talking, but we'll start off with 0 and do a breadth first search. The unique thing about breadth first search is that it lends itself really nicely to determining the shortest path between any node. Especially when it comes to saying, hey, what's the closest node to 0? That's a really easy question to ask when it comes to breadth first search. And we've already talked about how that is used in recommendation engines, peer-to-peer networks, even Google Maps, right? Facebook friend requests, and Instagram recommendations. Breadth first search, or BFS, allows us to convert a graph essentially into a tree, because we know who the children of the parent node is, and then the grandchildren, and then so on and so forth. So if you remember this diagram over here, we now understand that breadth first search, yes, it uses more memory to keep track of the parent nodes and the children nodes of that level. But it also helps us determine the shortest path, and it's better if we know that a node we're looking for is close to us, because it's going to look at the closer nodes first. So that when you get asked this in an interview, you know this algorithm is going to work well for these types of questions. Because breadth first search is crafted to help us determine the shortest path between two nodes in a graph.